Hey, I'm Austin Hutchison, and this is my video report for Lab 5, which I made about a bouncing ball. My purpose for this lab was to model the motion of a bouncing ball and then determine its change in internal energy during each bounce during the collision with the floor, and then compare the idealized model with my observations. I found that after each bounce, the ball went back up to about two-thirds of the height that it was at before the fall. Therefore, the ball lost about one-third of its energy during the collision with the floor. Now, for the main physical principles used in this lab, first is the energy principle, which states that changes in a system's total energy can only be brought about through external factors acting on it. Now, I guess also use mechanical energy, which just states that change in energy or mechanical energy is equal to the change in kinetic plus change in potential energy, and that those two kind of cancel each other out and equal zero. And of course, the kinetic energy formula, 1/mv squared, and then the change in gravitational potential energy, which is negative mg times the change in height. And finally, it's good to keep in mind that this experiment is an inelastic collision in which kinetic energy isn't conserved, but is converted into other forms during the collision, like during the contact between the two objects. So that's where internal energy is going to come in. Now, for some basic experiment details. The system was the ball in the earth, and I use nothing for the surroundings because it allows me to kind of ignore work and just focus on kinetic and potential energies. And then here's just some basic stuff about the ball, the mass, position, and initial velocity. Um, for this experiment, I assume that there were no external forces on the ball, like air resistance. Um, Basically meaning that every change in the energy is either kinetic or potential. And I also assume that the floor is totally hard, meaning it does not deform at all during the collision. Like it felt pretty hard, but I guess you never know. And then the energy principle equation for this experiment was that total E, chain L over delta E, is just equal to kinetic energy plus potential energy, and then the change in internal. So pretty basic stuff. Here, I'll show my video real quick. Now onto the actual experiment. Basically, what happens here is that all the ball's potential energy at the top of each bounce is converted to kinetic energy through the fall, and then at the bottom, it loses some internal energy, and then it just goes back and forth, converting into potential energy at the top, and then just kinetic potential. But I found this formula for velocity right before it hits the ground from this formula over here, and I basically calculated the velocity right before it hits the ground for each bounce. So right here, right here, right here. And as you can see, they were pretty close to the final velocities that I calculated from my actual observation data. And so yeah, they were pretty close, but they were not exact. Um, Probably because I kind of assumed that it was an ideal system and everything would just work out all fine and dandy. But and it's also hard because of tracker being inaccurate with like weird frame rates and stuff. But yeah. Now moving on, as you can see in the graph, after each bounce, the ball reaches about 67% of the height that it was at before the last collision with the ground. So after each collision with the ground, the ball retained 67% of its kinetic energy, which was then converted into potential energy on its way back up. Um, The rest was lost to factors like sound or likely deformation in the rubber ball during the collision. So the ball is actually going to lose a third of the energy that it has just during that collision. So that's why it's obviously going back up less height each time. Now for some discussion questions. What if the ball was totally solid and could not deform? In an ideal system with no external factors, like the floor also being hard and not deforming, the ball would likely continuously bounce back up to the same height as in an elastic collision. It would rebound with the same velocity, thus reach the same height as all its kinetic energy is converted to potential, and it would just do that over and over again forever. And finally, how could we find the magnitude of the contact force on the ball? I would say with a more exact measurement of delta t, we would be able to find the actual contact force on the ball by the floor. However, since we only know the change in energy and don't know the duration of contact, the magnitude of the force cannot be calculated. We do, however, know that it must be significantly greater than the gravitational force, because obviously it has to push the ball back up. But yeah, that's everything. So thank you for watching.